You all know the song, System of a Down said it best. The multiplicity of our city. Oh wait, no, that's different. Sometimes a polynomial has a factor that appears more than once. Oh my goodness, like the example we just did on the last slide. In example 1a, you had 3x to the fifth plus 18x to the fourth plus 27x to the third equals 0. Now, if you remember how that was factored, we moved this stuff around a little bit. It was 3x to the third, and then it factored to x plus 3 squared equals 0. So multiplicity shows, like, if you look at the graph here, you'll see the graph only crosses at -3 and 0. But multiplicity is kind of like a bend in that graph, a mathematical bend. You can't really see it on the graphs, even if it was zoomed way in. You can only see it when you have factored it correctly. So here's the deal. So 0 and -3 are the only two answers. But if you look, we have to the fifth degree, so there should be 5 different answers there. So I want you to think of 3x to the third as like 3 times x times x times x. X plus 3 squared is like x plus 3 times x plus 3. So if you look at it kind of expanded like that, it might be a little easier for you to see the multiplicity. Let me see, is there any spot where I have more room? No, there isn't. So you might look at this and be like, this x out here, well, that x could equal 0. The second x, oh, well, that x could also equal 0. This third x, oh, okay, well, x equals 0. And then you're like, well, how about this x plus 3? Well, this x could equal -3, and this x over here could equal -3. So the zeros, yes, they are 0 and -3. Should I squeak my shoe a little more? But the multiplicity, you can see over here, this x equals 0, x equals 0, x equals 0. That means 0 has a multiplicity of 3 factors of 0. This x equals -3 is in there twice, so it has a multiplicity of 2. Okay, so factor it, and then if stuff repeats, you say it has a multiplicity. So this one is a toughie. X to the third minus 9x squared plus 27x minus 27. Now, we haven't spent a lot of time on perfect cubes. We did difference of cubes in one of the previous sections, but this is a perfect cube. And some ways that you can recognize that are like, can you cube root that first term? Yeah. Cube root of x to the third is x. Can you cube root the last term, -27? Yeah, the cube root of -27 is -3, right? -3 times -3 times -3 gets you -27. So that might be a pretty good indicator for you that it is perfect cube. And this one is. And we're not, I mean, don't worry about it. It's fine. We're not going to spend a ton of time on those perfect cubes. But the other things you can look for are like, if you square that second term, -3 squared is 9. You'll see that number show up there. And -3 to the third power is again 27, and you'll see that number pop up there. So it does factor to x minus 3 to the third, which if that was stretched out, would be x minus 3 times x minus 3 times x minus 3, which would give us 3 answers, yeah? It would give us x equals +3 3 times. So we would say, for our final answer, we would say x is 3 and has a multiplicity of 3. Felicity of